Hello everyone. So this time we want to talk about the sketching the graph of a function. Okay, so this time we will design of the graph of this following function. So analyze and sketch the graph of fx equal to 2 times x squared minus 9 over x squared minus 4. Okay, so as you see, this is the rational function form. So in this case, there are several factors we need to find out before finding critical numbers and the inflection point. So first thing is vertical asymptote, or also possibly discontinuous point value as well. So let's do it. So I'm going to factor in this one, and 2 times x plus 3 and x minus 3 over x plus 2 and x minus 2. So do you see any common factor between the numerator and denominator? No, right? Then which means those two both are the vertical asymptote value. So we can find out vertical asymptote equal to x equals 2 and negative 2 as well. Okay, so what about the horizontal asymptote? So horizontal asymptote, we measure their degree of degree. So as you see, they are exactly same, which means we are taking their coefficient, which is 2 here. So I can say, y equal to 2 must be our horizontal asymptote. Okay, other factors. What about the x-intercept? So x-intercept means the numerator factor we set up equal to 0. Therefore, we can find out negative 3 comma 0 and then 3 comma 0. And what about the y-intercept? Y-intercept case, we are plugging 0 into x, so we can do 2 times 0 squared minus 9 over 0 squared minus 4, which means 2 times negative 9 over negative 4, so it become 9 over 2. So you can put 0 comma 9 over 2, or if you like decimal, then put 0 and 4.5 here. So basically we found basic information like a vertical asymptote, horizontal asymptote, and x and y intercept. So next part, we need to find out the critical value and then measure, how interval between increasing and decreasing. Okay, so then let's start derivative this given function. So in order to find out f prime x, we need to set up, this is the quotient rule setting. So t equal to 2x squared minus 18, and then b equal to x squared minus 4, then t primes for x, b prime 2x. We always do this direction first. So for x, x squared minus 4 minus 2x, 2x squared minus 18 over x squared minus 4 square. I'm gonna expand it and simplify. Then this is going to be 4x cubed minus 16x minus 4x cubed plus 36x over x cubed minus 4 square. So now we can cancel this out. So this becomes f prime x equal to 20x over x squared minus 4 square. Okay, so finding the critical value, we set up the numerator factor equal to 0. So it's the denominator. So this become 20x equal to 0. So we got x equal to 0. And then x squared minus 4 equal to 0. Therefore, x equal 2 and then minus 2. However, we know that those are already vertical asymptotes, so we don't use them anyway. Okay. Now, so far we found until Krieger value. So second step is inflection point. So we are doing second derivative. So second derivative also we need to use quotient. So t equal to 20x, b equal to x squared minus 4 square, then t prime 20, b prime 2x squared minus 4 times 2x, which means 4x times x squared minus 4. So same thing, we do this direction first, then this become 20 times x squared minus 4 square minus 20x times 4x x squared minus 4 over x squared minus 4 to the fourth power. Okay, simplify. So this time I'm using the factoring form, so that looks much easier. As you see, this is a common factor because it has here and here basically. So now we can say this is the x squared minus 4, take it out, then left over, so 20 times x squared minus 4 minus 80 x squared over x squared minus 4 fourth power. Okay, then this becomes, first of all, I can simplify this one cubic, and then 20 x squared minus 80 minus 80 x squared over x squared minus 4 to the cubic power. So simplify, then this become negative 60 x squared minus 80 over x squared minus 4 to the cubic. Okay, so far now we can make, so making numerator equal to 0 and also denominator equal to 0, then you can find the inflection point. So negative 60x squared minus 80 equal to 0, then 60x squared equal to negative 80, not possible. Now x squared minus 4 equal to 0. So far here, x equals 2 and negative 2. So now we can conclude that this is our vertical asymptote, but this is also involve the concave up and concave down shape. Okay, so I think we found all the information, and then first of all, I'm going to set up the graph, and then let's find out the graph shape. So first of all, I'm gonna define vertical asymptote, which is here, here, horizontal, here too, okay? And then we know x-intercept is negative 3 and 3. Y-intercept 4.5, so 1, 2, 3, 4.5 is right here. Okay, then now we need to determine interval of increasing and decreasing. So I will just set up right here and then measure that. So we have only one critical value, and then we set up two vertical asymptotes because they are automatic boundary value. So you have to use it. So testing value becomes, I'm going to choose negative 3, negative 1, 1. Oh, sorry, this is the 2, sorry. 3 here, okay. Now we want to define the interval for increasing and decreasing. So which function do you have to plug those values into? Original fx or f prime x or f second prime x? Yes, whenever we determine increasing and decreasing interval, we are using f prime x. So we know the f prime x was 20x over x squared minus 4 square. Okay. Now, when you look at this carefully, this no matter what become positive, right? Because we do square, which means if we only evaluate this numerator factor, then you can find whether it become increasing or decreasing. Okay, so -3, I can see this is decreasing because 20 times -3 become -60, so decreasing. -1 also decreasing. 1 increasing, 3 increasing. Good? Okay, then now let's do concave up and down case. So I'm gonna do the inflection point like that. Then I'm gonna start using same -3 and 3 as testing value. And here I will use 0 here. Okay, so f second prime was -60 x squared minus 80 over x squared minus 4 to the cubic power. Okay, so now this time we have cubic power here, so we need to find out both the numerator and denominator their sign. Okay, one thing is, so look this one carefully. Because we have x squared here, so no matter what value we input, this one no matter become negative, because on -60 times the square value become negative minus 80. So now we know this become negative all the time. So we only care about the bottom part here. So denominator become negative, then it will be positive. Denominator become negative, then this become positive basically. Okay, so -3, then 9 minus 4, right? So this is positive. So positive, negative, positive become negative. So this becomes CD. Now 0, then become 0 minus 4 basically. So it become negative. So negative or negative become positive. So CU. Now 3, then 3 is 9 minus 4 again. So become positive. So negative over positive become negative. So CD here. Make sense so far? Okay. Then now we are going back here. So based on this, until -3, actually until 0, but we have vertical asymptote, it never touch here. So this should be become negative and decreasing, and then CD. Okay. So we have a concave down is this shape here. Okay. Which one is decreasing concave down? Which is this shape, right? There should be this direction. Okay, therefore, if I follow that, this graph shape become like this. Okay, make sense? All right, then. Now, so until 0, it is decreasing and concave up. Now, after 0, increasing concave up. So that shape must be this then. Okay, so I can draw the picture here. Looks like this. And then now 3, increasing and concave down. So increasing concave down is this one then now. Okay, so I can make this. Okay, so there will be the graph of this function. I know I'm not drawing that really pretty, but that's the graph of the given function. Okay.